Okay, verify. Any bright ideas? Here? Okay. So remember, in the guidelines, it was, I think, step 4. It said, if you can't think of anything else, try to change them into cosines and sines. In this case, what's on the left, if we work on what's on the left, I mean, that already is a cosine. So let's say we've turned this into cosines and sines. Since it's cotangent, that would be cosine squared over sine squared. And we still have our minus cosine squared of x. Okay, how does that help us along? Right, by doing that, we created a denominator in one of the terms. So now, in order to add the terms, we need a common denominator. And that's often the way that this starts to simplify. What would I need to multiply? Yeah, this one here doesn't have the sine squared in the denominator, so we'll multiply by sine squared over sine squared. And now, both terms have the same common denominator. We can combine the numerators. Right? That's cosine squared x minus cosine squared x sine squared x divided by sine squared x. Say again? Could you? You bet, right? You've got two terms in the numerator, and they both got a cosine squared in it. Factor it out. Right, so here we get cosine squared x times 1 minus sine squared x. And that is all over sine squared x. Okay, what suggests itself now? It's a form of that identity. What is it equal to? It's cosine squared, right? By that same identity here, right? If I subtract sine squared to this side, then I've got 1 minus sine squared equals cosine squared. So I'm going to say this is cosine squared x times cosine squared x divided by, and I'm just going to write it here because it doesn't matter, sine squared x. Okay, but yeah, now this cosine squared over sine squared, there's your cotangent squared. And the cosine squared is good as it is. So this is cotangent squared, cosine squared. And that's done.